in this part of the lesson, so it is handout 9. We are still working on handout 9 and part 2. In this part of the lesson, we will focus our attention on area between two curves. Now, before we discuss that, let me ask you a couple of questions here. Suppose I have a function here. Let's say this is my function f of x. Let's say g of x, or maybe let's say f of x. And if I write a to b f of x dx, then what does that mean? Let's say this is your a and this is your b. What it means is basically I'm looking for area, this area, right? This is the area that I'm looking for. Okay. Now, if let's say I have another function, this, and this function is, let's say, g of x. Now, if I write a to b g of x dx, then what does that mean? This represents the area, all the area below this. So that means basically it represents this part plus this part, everything right below that. Now, if I want to find the area between these two curves, so between these two curves means just the green part only, that part. What should I do? I just subtract the below one, right? I need to subtract this part. So if I subtract that, I'm gonna get this right here. So area between the two curves is given by a to b g of x dx minus a to b f of x dx, provided that g is bigger here. G of x is greater than f of x. Notice that we always subtract the small function from the larger function. Okay, if you subtract the larger function from the small function, that doesn't make, that doesn't make sense actually. All right, so what we know is that, okay, I don't know why this is not, I want to erase this. Okay, this is not going somehow. Anyway, so now this can be written as you can see, I can write this as a to b g of x minus f of x dx. So I can write this as this way, provided g is greater. If f is greater, then it will reverse. So f of x minus g of x. So this area is actually written as, given by a to b g of x minus f of x dx. So okay, that's how we can find the area between the curves. Now, sometimes what happens is that, let's look at another simple example. Let's say I have a function here, which is my f of x, and I have another function here. This is g of x. Let me draw. Oh, okay, anyway, this one is f of x. The red one is f of x, and the blue one is g of x, let's say. Now, if I want to find the area between, let's say, between A and B, for example. So that means I'm looking for this area plus this area, right? These are the two areas I'm looking for, area between the curves. Now, what will be the formula? So what is this part? This part, in this case, your g function is bigger. So this part will be A2, and we need to know this is the point of intersection. Let's say this is C. Notice that this is your point of intersection. So from A to C, your g function is bigger, so g of x minus f of x dx. All right, so this is the area given, I mean, this area is given by this integral. Now, in this case, notice that from C to B, your f function is bigger. So you'll write f of x minus g of x dx. All right, so if you want to write area between the curves, so area between the curves f of x and g of x is given by A to C g of x minus f of x dx plus C to B f of x minus g of x dx, provided where z is bigger than f of x on the interval A to C, right? On the interval A to C, z is bigger and f is bigger on the interval C to B. Okay, this is the main thing that you need to know. So what we notice is that, first of all, we need to figure out which function is bigger, right? Which function is a greater function. And then we can just find the area without difficulties. So let's look at this example 3. Find the area bounded by 4 minus x squared. F of x is 4 minus x squared. G of x is x plus 2 and x equals -2 and x equals 1. You know, these two functions are very simple function, and so you may want to draw the graph. If you draw the graph looks like this. Here is the graph, guys. Okay, this is your f of x, the green line, the parabola, because it is 4 minus x squared, and you know that this is a parabola which opens down. So this is my f of x, and g of x is the red linear line. X plus 2 is, of course, linear, right? A straight line. So this is g of x. Now, by looking at the graph, you can tell me that f is bigger, right? We need to find -2 is right there all the way to 1. This is your A and this is your B. So throughout the interval, f is bigger. So clearly, f of x is greater than g of x on the interval -2 and 1. Okay, so area between the curves or bounded by the curves, let me write area bounded by the curves, bounded by the given curves, equals A to B f of x minus g of x dx. All right, now your A is -2, b is 1, f is 4 minus x square minus g of x. So let me just write directly. So this is 4 minus x square minus x minus 2 dx. And that's going to give me -2 to 1. So if you simplify it, if you combine the like terms, so you're going to get 2 minus x square minus x dx. And now if you want to find the antiderivative of that, you're going to get 2x minus x cubed over 3 minus x squared over 2, and this will be -2 to 1. And now you just evaluate this one and let me know what is the answer. You substitute the upper limit, which is 2 times 1 minus 1 cube over 3 minus 1 square over 2, and then substitute the lower limit, which is 2 times -2 minus -2 cube over 3 minus -2 square over 2. And so if you simplify it, I trust that you'll be able to evaluate this without any difficulty. And my calculator tells me it is 9/2, but I want to verify my answer with you guys. So can you tell me whether you got the same thing? Just answer in the chat box, please. Okay, if you have any question, let me know. So this is what we got. 4.5 is the area bounded by the curve. So that means if you look at this graphically, we are talking about this area right here. So this area is 4.5. All right. Now look at example 4. In example 4, we want to find the area of region bounded by the graphs. So we are given two graphs and the interval is not given. Okay, remember the formula is A to B. So how do you find the interval here? That's my question to you. And which function is bigger? And which function is smaller? If f of x is bigger or g of x is bigger? And what is the interval? So a couple of things to think. So to find the interval, let me just draw the graph and what happens, because drawing graph of this function is not that difficult. They are pretty straightforward, simple function. And if I draw the graph, notice that this is my g of x, because g of x is a parabola opening up, and this is my f of x, which is a straight line. Notice that f of x is bigger here throughout the interval. So the interval will be actually the point of intersection here, because if the interval is not given, then we find the point of intersection of these curves, and that will serve as the interval. So if you just draw the graph, then everything will be pretty clear here, right? So let us find the point of intersection. First, we find point of intersection. So always point of intersection is either f of x equals g of x or g of x equals f of x. So when these two functions have the same value, and that's the point of intersection always. So this means it is x squared plus 1 equals 2x plus 1. And this means x squared minus 2x equals 0. And this means x times x minus 2 equal to 0. And which means x equal to 0 and 2. So basically what we got the interval here as 0 and 2. So now So we need to find, and hold on a second, hold a second here. So now we already know that f is greater than g of x. Okay, so clearly f of x is greater than g of x on the interval 0 to 2. We know that. So area bounded by the given curves, okay, curves equals a to b f of x minus g of x dx. And so a is 0, b is 2, f is 2x plus 1 minus g of x is minus x squared minus 1 dx, and this is gonna give me 0 to 2. So I'll get 2x minus x squared dx. And now you can evaluate this integral. This is a piece of cake for you. So yeah, try this. So this will be 2x squared over 2 minus x cubed over 3, 0 to 2. And so we're going to get 2 squared minus 2 cubed over 3 minus 0 squared minus, okay, this whole 0, so I don't have to write that. It is simply 0. And so your answer is going to be, if you simplify it, your answer looks like 4 over 3. Any question? So in the previous example, what we did is we draw the graph of the given curves, and then we figure out which function is bigger and which one is smaller in the given interval. And that's nice. If you know how to draw the graph exactly, then that's pretty good. No issue there. But sometimes life is not that easy always, right? Sometimes life is not that easy. Sometimes they give you a function which is a little bit difficult to draw the graph. Look at this example 6. I don't know how many of you love to draw this kind of graph. It's not that bad. You can still draw the graph, but if I give you functions like y equals 2 e raised to power 2x plus x raised to power 7 over 3 plus ln x, something like that, then drawing this kind of graph is not fun, right? It's not fun. It's a little bit challenging. So now the question is, if you don't want to draw the graph, can you still find the area bounded by the curves? The short answer is yes. Okay, if you find that drawing graph is a little bit difficult for you, then don't worry, don't be scared. We're going to learn another technique, and then we'll figure out how to find the area bounded by the curve. So example 5 and 6 are very similar, and I want to do example 5, and then you will do example 6 on your own with using the same idea. Okay, so example 5, find the area bounded by the curve, and suppose we don't want to draw the graph. Even this, drawing graph here is not that difficult. It's pretty easy, simple function. But let us suppose that we don't want to draw the graph. Then how do we find the interval, and how do we find which function is bigger and which function is smaller? So first of all, find the point of intersection. Sometimes what happens is that even though the interval is given, look at this example that we discussed. Even though the interval is given a to b, sometimes there is a point of intersection, and that point of intersection on the left side, one function may be bigger, another side, another function may be bigger. So therefore, always find point of intersection. Okay, first we'll find point of intersection. First, we find point of intersection. Oh, by the way, this one is y, this one is y. Can I do this? Let's do this. Let us suppose that my function f of x is 2x and g of x is x squared minus 3. Okay, let us suppose that, because then we can, we can represent this by f and g, and it will make things more clear. So let us do that first. Now, first find point of intersection, which means you can write either f of x equal to g of x or g of x equal to f of x, doesn't matter. Which gives me x squared minus 3 equals 2x, which gives me x squared minus 2x minus 3 equal to 0. And solve this and let me know what is the value of x. Okay, guys, I'll wait for you. And give me your answer in the chat box. Okay, you guys got the answer as x equals, you got two value, which is -1 and 3. Because so many of you got the same answer, I trust that this is the correct one, because it's very difficult to get the same wrong answer. And let's now remember here, the interval a and b is given there, and the functions will intersect at these 2 points. But in these 2 points, 3 is not in the given interval. In another word, x equals to 3 is not in the domain. Okay, so the only intersection point within the on the interval within -2 and 1 is -1. So x equals to 3 is not in the domain. In another word, you can also say that x equals 3 is not in the domain. You can also say this if you like. All right, so now remember, here what happened is that we have a given interval. So the given interval was -2 and 1. And now there is -1 where the function has intersection point. So this means what we can say here is that this divides our interval into 2. So now we need to check each of the function, which one is bigger in -2 to -1 and -1 and 1. So we need to test, we need to check in both of the interval, which one is bigger in what interval. Okay, so on the interval, let me just write on -2 and -1. So what happens? On this interval, which function is bigger? Well, the easiest method would be choose any random point between -1 and 1. Any point there. I call it testing point. Okay, so let us choose that the testing point x equals -1.5. All right, you can choose x equals to -1.7, -1.8, -0, -1.2, doesn't matter. Any number between -2 and -1, any number. But to make life easy, I choose x equals negative 1.5. Now, all you need to do is, if you substitute this value in the f function, now f of negative 1.5 is how much? You calculate that, which means 2 times negative 1.5, which gives me, how much is this? Negative 3. And g of, now substitute the same testing point in the g function, which gives me a negative 1.5 square minus 3. How much is that? Negative 1.5 square will be positive 2.25 minus 3 will be negative 0.75. Now compare these two. Which one is bigger? Clearly, g is bigger, right? G is bigger because negative 0.75 is bigger than negative 3. So g is bigger. Okay. In the same manner, let us test in negative 1 and 1 what happens. Testing point. X equals, choose any point between negative 1 and 1. I think the easiest number, if you want to make your life easy, you may want to choose x equal to 0. So then what happens? If you substitute this testing point in the f function, f of 0, so that's going to give me 2 times 0, which is 0, and z of 0, which is 0 square minus 3, which gives me negative 3. And clearly you can compare this 0 and negative 3. Which one is bigger? 0 is bigger, right? So you'll have f of x is greater than g of x. Okay, so we can find the area between two curves. So area between curves is given by, from negative 2 to negative 1, okay, on this negative 2 and negative 1, g is bigger. And from negative 1 to 1, which one is bigger? F is bigger. F of x minus g of x dx. Okay, now let us just substitute the value. Okay, so that means negative 2 to negative 1. Z function is, what is Z function here? Z is x squared minus 3 and minus 2x dx plus negative 1 to 1. Your f is bigger, which is 2x minus x squared, and negative will be positive 3 dx. So now this is a piece of cake for you. So you can evaluate the integral and substitute the limit, and then let me know what is the answer. So that's going to give me x cubed over 3 minus 3x minus 2x squared over 2, so that I can simply write x squared there, x squared, and negative 2 to negative 1. Okay, the first integral will be that, plus the second integral will be, again same, this will be 2x squared over 2, which means I can simply write x squared and minus x cubed over 3 plus 3x, and so the lower limit is negative 1 to 1. And just plug in the value and let me know the answer. So once you calculate the final answer, please write your answer in the chat box. Okay, Simarjot, why the lower limit is -2? Because lower limit is -2, it is given. You see here in the question? See here, x -2, and that is the lowest here. And so what I got here is that the first integral, the first part, this is what I got, 5/3. And the second part I got 6, and I want to verify this answer with you guys, and this will be all together. My final answer will be 23/3. Okay, this is what I got, but I want to verify my answer with you guys. Okay, guys, so many of you got the same answer, 23/3. In the you wrote that answer in the chat box, and I trust that this is the correct one. Now, if you want to draw the graph, and if you look at this graphically, and this is what you will get. Okay, so what we found is that the graph has intersection at x equals -1, and that makes sense if you draw the graph. And we notice that this is our f function is this, and z function is this, and we notice that -2 to -1, z is bigger. Okay, this z is bigger, and from -1 to here we notice that this is bigger. Okay, and that makes sense. All right, so this is all about area bounded by the curves. And here is one question. It is very similar to example 5, not a big deal, because we already learned how to find the area bounded by the given curves without drawing the graph. And in example 6, if you want to draw the graph, great, fine, no problem. But if you don't want to do the graph, then that's also okay, using the same method that we just learned. And I want you to try this example 6 just for fun, okay? Just for fun.